We're getting to the good part here. The second half of Chapter 8 has us classifying chemical reactions in order to predict their products. Eventually, I want to be able to just give you two reactants, and you can tell me what's going to happen if we mix them together in the lab. Now, to do that, we're going to classify the reaction and put them in one of 5 categories. Our first option is a combustion. In a combustion, you'll have some kind of an organic compound reacting with oxygen to produce carbon dioxide and water. So 75% of a combustion equation is always the same. It's some kind of an organic compound, organic meaning carbon. Some kind of a carbon compound. So here's 2 combustion reactions. Now the carbon compound might be a little different, but the rest of it is all the same. The carbon compound is reacting with oxygen, diatomic oxygen gas, to produce carbon dioxide gas. And notice the water is listed as water vapor. Now you might remember earlier in the course we did a lab where we were testing a bunch of substances to see if they were ionic or covalent, and one of the tests that we ran was a combustion test, which meant that something was burning. In a combustion, you should have an exothermic reaction. Your organic is burning in the presence of oxygen to produce carbon dioxide and water vapor. And since it is exothermic, often the energy released will evaporate the water. This first reaction actually is the equation for the combustion of methane gas. That's what happens when you light the Bunsen burner. So you light the Bunsen burner and you don't see little water liquid droplets flying down from the sky. No, the water evaporates with the energy that's produced from the reaction. Now sometimes you might see energy written as a product, which is fine. Or sometimes they might just say like methane gas burns in the presence of oxygen. And then I would kind of understand that it is exothermic. If something is burning, energy is released. Alright, so let's do a few of these. With the organic compounds, we'll probably need to draw their structures to get the formulas. If I want to write the chemical equation for the combustion of propane, I might need to draw propane. Prop is the organic prefix for 3 carbons. Ane means single bonded. And then we'll give all carbons an octet. Give him a full outer shell. There you go. And then we know we're going to have 3 carbons. We've got 2, 4, 6, 7, 8 hydrogens. So propane is C3H8. Now all they tell me is the combustion of propane. They don't tell me any of the reactants besides propane or the products. But if they use the word combustion, I know the rest of the equation. Combustion means the organic compound is burning or reacting with oxygen, diatomic, and the products are always the same: carbon dioxide and water. Now, depending on your organic, these might balance a little differently, but they're not that bad, right? So I have 3 carbon, 8 hydrogen, 4 times 2 is 8, and then we just want to make sure the total number of oxygen balances on both sides. So here's 3 times 2 for 6, plus 4. I have a total of 10 oxygen on the product side, and 5 times 2 is 10. Done. Now the last thing that we should do with these equations now is add the phase symbols. The phase symbols just give us a little more detail on what to expect if I really run this reaction in a lab. Propane is a gas. They're kind of hinting at that. O2 oxygen is a gas. The carbon dioxide is a gas. And And again, we mentioned that this would be water vapor. Water in the vapor phase. We're going to run a bunch of these reactions in class, in the lab, so that we'll kind of see, oh yeah, you often don't experience liquid water after a combustion. Although I'll do a combustion for you in class where we can condense the vapors and prove that there is water present. There, done, a combustion. Now you might see this worded a little differently. So the second example is the combustion of liquid ethanol. They could also word this as ethanol burns in oxygen. Or maybe they say ethanol burns in the presence of oxygen or something like that. Oxygen is required for combustion. We need oxygen in order for something to burn. Which is why I think we've also kind of mentioned that if you had something on fire in the lab and you didn't want it to be on fire, just take away its oxygen source. Smother the flame, it'll eventually go out. Ethanol. So I probably need to draw this one. F is the organic prefix for 2 carbons. Single bonded. The anol ending means it's an alcohol. Alcohols have an OH group somewhere on the carbon chain. You can put it wherever you want. So I don't know, maybe I'll just kind of hang it off the bottom. Then we'll fill up the rest of carbons, octet, with hydrogen. So the formula is often written as C2H5OH. I have 2 carbon. Surrounding the 2 carbon are 5 hydrogen, and the 6th position is a hydroxide group. So again, if they say that it burns in oxygen, it just means that we're reacting the ethanol with oxygen gas, diatomic. And if you have an organic burning in oxygen, your products are carbon dioxide and water. And then all we have to do is balance. So these will balance a little differently, but again, 75% of the reaction is the same. So I need 2 carbon, 2 carbon. I have a total of 6 hydrogen on my reactant side. So 3 times 2 is 6. And then I have 2 times 2, 4 oxygen, plus another 3 for 7. And I don't really want to mess up this ethanol molecule because right now I have carbon and hydrogen balanced. So in order to get my 7 oxygen, I'll count this as 1, and here's the other 6. Got it. Not so bad, right? I'm hoping that by now the balancing is starting to come along. And the last thing we do, phase symbols. They kind of hint that this is a liquid ethanol. Oxygen is a gas. Carbon dioxide is a gas. And we are burning the ethanol, and the energy released will evaporate the water. So instead of liquid, it'll be water vapor. So often a combustion is pretty easy to pick out of a stack of equations. Look for that organic compound reacting with oxygen. And the products are always, always, always the same. Carbon dioxide and water.